Welcome to episode 14 of Tacit Talk. I am your host, Conor, and today with us, I have a special guest, Madeline Vergani, who goes by sometimes on the socials at Rubenberg, and we will list those in both the description of the YouTube video. I think maybe one of them is already there, and also on the website and in the podcast show notes if you are listening to the audio-only version. If you are also a listener of Arraycast, you will recognize her name from episode 88, where we talked about her language, which you, if you're watching the YouTube live stream or the recording, you are seeing it on the screen. TinyAPL is the language. It is a super exciting language in that it is called TinyAPL, but it has almost all of the glyphs and features from many of the array languages. And we're going to talk about that today. We might talk about Omnibar as well, one of Madeline's other projects, which is super cool. And then at the tail end of this conversation, we might even talk about plans for a future language. Welcome to the show, Madeline.
Hi. For the past year and a half, I've been working on TinyAPL, and it's a really interesting project, I think, because it wants to be like a playground for experimentation on primitive design, both by me, but also by other people who suggest some primitives, and I usually add them. So, we discuss what's the point, and then if they're interesting, I just implement everything. And it's not really tiny, but it used to be, I guess.
Yeah, we will definitely. So I spent over the last, I think it was not week, I think on Wednesday. So today it's a very chilly in Toronto, Canada, Saturday morning. And I think it was, 3 days ago, I started adding TinyAPL to my GitHub repo, which I think is called Array Language Comparisons, which it doesn't just compare languages, it compares a number of libraries as well. I guess, you're bringing it up on stream here. And so now TinyAPL is in this repository, and a part of that is adding a bunch of sort of indications, I think, and there might even be a couple mistakes, because I saw in your .12 release notes or something that you said that you were changing the way that index origin worked, and one of the things on the README at the beginning is whether it is a 0, 1 or has a quad IO. So that might be a mistake. I'm not sure. We can answer that now. What is the index origin story for TinyAPL?
Well, it's none of the three, technically. It used to be 1, but then I switched to 0 a couple of versions ago. But now in the latest release, which, hasn't been released yet, but in the beta here, there is a way to configure it, which is not quad IO like in dialog. It's called extra argument, so you can talk about it later for sure. But for now, the short version is this: if you type this, maybe it's a bit small. If you type this glyph next to another primitive, it becomes index origin 1. So I don't know. IOTA 10 is from 0 to 9, but if I do IOTA with index origin 1 to 10, it's 1 to 10.
Interesting. So it's like a modifier. Yeah, and I guess that's a question. What is the word that you have chosen to adopt for modifiers or operators? Because APL calls them operators, BQN, Uiua call them modifiers, J, depending on the arity, calls them modifiers at the top level, and then adverbs and conjunctions. What's the terminology TinyAPL uses?
The official terminology is modifier and adverb and conjunction, like in J, but internally, some places still call them operators because I forgot to change them mostly. But the official name is modifiers.
Okay, modifiers. And I guess we're hopping straight into things. So I mean, in part of the adding it to the array languages repository, and also I think yesterday I also added it to the top 10 GitHub repo as well. I noticed that there are a lot of J influences, including just now you mentioned the adverbs and conjunctions, but also too the I think you call them on prefixes, and I'm not sure if on suffixes was the other one, or on infixes. There's a couple of them. That is almost, I think, directly taken from the J language. Do you want to talk about the inspirations? Because obviously you're taking primitives and you're taking ideas from all the different array languages, but definitely there seems to be I'm not sure if you want to say that J is like the biggest influence in terms of primitives, or just J has more primitives? Like, talk us through the inspiration and sort of where you're taking things from with TinyAPL.
Yeah, there's lots of things from different array languages. The ones you were talking about are the double up arrow and double down arrow glyphs, which are from J, so onion fixes, which is like windows, prefixes, which is prefixes and suffixes. There's also outfixes, which is like the opposite of windows. It gives you closer functions on the part of the array that are not in a window. I haven't implemented that yet, but there are three I have. And yes, they are from J, but they are placed a little bit differently. Because in J, the same glyph uses both prefixes and infixes, and the other one is suffixes and outfixes. I swapped them, so one glyph is prefixes and outfixes, and the other one is suffixes and infixes. The reason is that if I go to the take, not the drop, maybe that's better, to the drop documentation page, docs, there is an extension that I haven't implemented yet, which is called infix. Basically, if you give it a nested array as the left argument, it drops both on the beginning and the end. So because infix is on the down arrow, I put the down arrow to be the on infixes operator. I'm going to show it right now. If I do box on infixes of length 2 on iota 10, it gives me the windows of length 2. If you combine that with a reduction, so maybe minus reduce, it, well, of course, it's not minus 1.
Right. Yeah,
it's like windowed reduction from APL, from dialog. I chose this way instead of having windowed reduction because it's more flexible. You can, it's much more general. First of all, you can say, I want chunks, for example, 2, 1, I think. No, sorry. 2, 2. I can't remember. There's a way to tell it that you want chunks. There's also a way to say how much you want to skip, and
I think the chunks, if it's the same as J, I think it's a negative integer specifies.
Yes, you can do that. Oh, wait. I forgot the infixes. No. Okay. Yeah, this one does chunks. There's another more general way. You can take it now. It's a very complex primitive. There's a lot of modes of how to do different things. You can tell it how to fill when there is not enough elements. You can tell it if it should stop when it finds the last element, or if it should continue all the way to the end. It's a very complex primitive. Some parts I haven't implemented yet, but yeah, the monad, this one is diet, right? So you pass the size on the left and the area on the right. Mm-hmm. If you call it monadically, it does the prefixes and suffixes. So if I box the prefixes, it gives you each prefix. Right. The glyphs are inspired by BQN. In BQN, the normal up arrow monadically gives you the prefixes as a function, not as a modifier. Right. So that's what the glyphs come from. But like J, it's an operator, it's a modifier. So you can give it a function. You can say sum the prefixes, and that becomes a scan. So I don't have scan. I only have like J. I have reduction plus infixes and suffixes. This is more general because APL has that problem with the quadratic scan, which scans left to right, but then reduces right to left. So you can do this if you want. You can do a right to left reduction. It's going to be the same because it's plus B. Maybe minus is a better example. If I do subtraction or reduction from the left, it's different than subtraction or reduction from the right. And the second one here is the quadratic scan from dialog. But if you want, you can choose the more sane version, I guess, which is both reducing and scanning from the left. You can also reduce and scan from the right, or reduce from the right and scan from the left. But another big... I'm going to go to the wiki right now and see the official list of inspiration, which Marshall wrote. But yeah, I think things a lot. Yes, but dialog, of course, is where most of the primitives come from. There's a few things from BQN. Group is the most important. I can show it later. From J, from cap, I have the forks mostly. And then for extended dialog, we all have pair and the at depth operator and some other things. So yeah, the fork is basically a pair of conjunctions that create a tree train, basically. There is another way to do trains, which is more general. But if I just want to say like the sum minus the product, I can use these two normal conjunctions to make the, the the fork. Yeah, from BQN I have group, which is here, I think. Yeah, so group basically say 1, 0, 3, and you press it 1, 2, 3. Okay, so this says I'm pointing at my screen, but you can see that. So the 1 here says that the first element goes in the second group, and 0 says the second element goes in the first group. And then 3 says that the third element goes in the fourth group. So you can see that group number 0 has a 2, group number 1 has a 1, and then nothing, and then group number 3 has the 3. So yeah, this is straight from BQN. I also have join from BQN, which is like catenation reduction, but with implicit each. So if I do, I have a list 1, 2, 3, 4, 5. That's 2 vectors. I can join them into a single vector. I think that's most of the inspirations for the important things.
Well, so I have a bunch of thoughts and questions. My first one is that technically, and this is on the, we'll link it in the show notes, yes, and / description. The pull request that I opened, I kind of labeled the things that I loved, the things that I was neutral about or didn't know, and then the things that I was less a fan of. One of the top ones was that outer product, famously, across the most popular array languages, almost has a different glyph every single time. In TinyAPL, it's the jot dot. Then BQN came along and added it as the kind of angle, if you will, or L-shaped table glyph. Then Uiua came along, or I guess Cap was before Uiua, and Cap, they use it as a rectangle with a jot enclosed. Oh, wait, hold it. Holy smokes. Holy smokes. This is amazing, folks. Literally, I had plans to say that, like, Omnibar... Okay, all right, back up. For the audio listener, Madeline has gone to her Omnibar site, which I've tweeted about. I think we chatted about it at the end of the Arraycast, episode 88, and it is an amalgamation of basically every APL that exists under the sun, and it uses a beautiful, I'm not sure if you stole the color palette from Excel 2003, but it's either exactly that color palette or it's just very close. Warms my heart. I love to see it. And you can search basically across languages to see which languages include operations and glyphs. The one thing that I was going to say is what I really want is to be able to compare what the glyphs look like across a single glyph or for a single glyph across languages. And Madeline went ahead and typed in outer product, and then this feature apparently already exists. It already exists, folks. I mean, a glaring omission from the outer product glyphs that we're looking at is TinyAPL, because that glyph is not there. So actually, walk me through, because I just explained jot dot. Interesting. Cap uses it includes both both glyphs for each of them.
I think this first one, which is a jot and then a high dot, is like for backwards compatibility. I don't think it's intended to be used. But it's there, so I see.
It's like backwards compatibility kind of thing. Okay, so we'll kind of ignore that one then. So yeah, jot dot is like n-4 of n equal to like 20 or something like that for most APLs. And so actually BQN, there's a good question. Are there plans, or does it really fit with the system for a language like BQN or a language like Uiua to be added? Because that's really what I would love to see, because technically Uiua not an APL or like the furthest from an APL of all of the array languages in the Iversonian bubble, but they still use glyphs. So I don't know. What are your thoughts on fringe APL or like on the cusp of being an APL languages?
Well, BQN, I had originally decided that it was out of scope because the original idea for Omnibar was to be a list of all the glyphs when you create a new font. So I wanted to make a new font for APL, and I needed to have a list of all the glyphs used in any dialect. And for that original reason, BQN doesn't really fit because it's a completely different language. But it's evolved to be more of a comparison tool. So maybe it's useful and I should include it. Maybe I should have like a checkbox to hide it by default, but enable it if you want.
Yeah. That would be, not that I'm trying to put extra work, because I know you're very busy developing TinyAPL and such, but yeah, that is it. I mean, just even the fact that modulo BQN and Uiua, you're able to do this, because this is, to close up our tangent. This is exactly what I was saying, is that TinyAPL has potentially, I don't actually know if you borrowed it from Uiua, but I was going to get back to saying that maybe Uiua should be on the list of languages that inspired, because, and I will say that it is one of my favorite, well, I shouldn't say it's my favorite thing about, or one of my favorite, because it's a very small thing. But when I saw it, I was definitely like, oh, that's amazing. Because I actually at one point was messing around with creating like a super small APL just for like, for fun and like the art of, whatever, rebuilding your own wheel. And that was the glyph that I had chosen, even before Uiua or TinyAPL were on the scene, because I think it's perfect. Like it's exactly what you're doing. You're creating a table of things, right? And I guess we haven't even described it. The poor audio listener is like, what are they talking about? Uiua and TinyAPL, they use a basically square with a cross. Technically, it's named after some saint, either St. Michael's or St. George. I don't know which one, but it is the one that looks like a small T, like the flag of England, if you will. And yeah, so you chose that. So did that come from Uiua, or did you stumble across that yourself?
No, I think it's a very natural choice for the operation. So I think I didn't even know about Uiua when I picked it. It's from another language which I wanted to design, but it was too big and I didn't know where to start. But in the original plans for a language back in like 2021, I think, I had already this glyph. So I don't think I even knew about Uiua back then.
Oh, I guess that's a good point. So when did TinyAPL, when was it like first available? Because I know you've been writing blog posts and kind of updating, I guess, folks that are reading it while you've been developing this. So as you've been developing it, you've kind of been doing it in public. Because I know Uiua wasn't announced, I guess, until 2023, September-ish. And, wow, that's already almost a year and a half ago at this point. And this one says TinyAPL 0.1.00, March 11th. So I guess technically slightly after, but you might not have been aware of it at that point. Yeah.
Yeah. The first blog post, I think, is from August 2023. In the first part, I just implemented like the array model and the functions and things. The first actual version, which had a parser and you could actually run, was in March 2024. So by then, I just didn't know about it, I guess, but it probably already existed.
Very cool. Very cool. Well, now that I know that you have this functionality built into Omnibar, and actually, wait, I got too many questions. I got to pop off the stack here very quickly because I'm gonna lose track of them. I've noticed that in the code that you were writing earlier, showing the scans, you were using slashes for the reductions, which I guess for the folks that are listening to this podcast and I don't even think it came up on episode 88, but in the .11 release, not because we're looking at the beta, so this is going to be the .12, you were using a pipe with either a left or right arrow into it. I'm curious, this was one of the things on the pull request where I put like a thinking face, which is that I wasn't in love with it, I didn't hate it, I was more just like every single array language I think. Like, if you list all the ones that have been guests on ArrayCast, like even including Q, which is like Q is like the least Iversonian E of the Iversonian array languages because they use keywords for most of the stuff. Even Q uses slashes. I think technically they have over and fold as keywords, or over and scan as keywords. So I'm curious, did this come from a different language? Was this a personal choice? Yeah, walk us through. And so it seems like now you've switched to be similar, to use the slash and backslash. So yeah, what's the history behind this glyph?
Well, the first time I added reduction used a third glyph. Let's see if I think it's on the blog. There should be a whole thing about reduction. Yeah, reductions. I used like an up arrow, a down arrow and an up arrow. I can't find it. Direction, yeah. I had scans originally as well. So I used up and down arrows with a single stroke for reduction and with 2 strokes for scanning. But then after I wrote this post, I decided that I wanted to do the J things of prefixes and suffixes. So, having a single and double stroke thing didn't make sense anymore because the double stroke versions were removed. So I just went looking through Unicode to find some glyphs that were, showed what the reduction does, because not many array languages have both a left and right reduction. So I wanted a pair of glyphs that showed the difference. So
I see.
I actually went to the right arrow that with the bar to show reduction from left to right. And then we reduce back, which is the opposite primitive, is a left arrow with a vertical bar. But then I'm not sure why I changed it, actually. I just felt that it was too busy for a common operation like that. So I went with I changed it just this morning. So slash is the left to right reduction, which is not like other APLs, I guess. But it's also first axis, so it's different already. And then the backslash is the right to left reduction. It's not scan, it's the reduction from the other way.
Oh. Right. Because scan is maps to prefixes. Interesting. So yeah, it just we'll repeat in case the listener or the viewer didn't catch that TinyAPL has both left folds or left reduces and right folds and right reduces, which honestly I should have intuited that was the reason you reached for a different glyph, because you wanted some kind of symmetry between the left and fold versions of that primitive, which other languages don't have, which leads to issues in that. That is one of my four or five major problems with Dialog APL. Is I consider that the default behavior of their scan to be broken, because sure, if you want your continued fractions or your alternating sums, that's exactly what you want. But that is like two little mathematical coding tricks that I've never actually needed in writing code. And then it leads to a bunch of if you have the proper scan, which is what BQN and CAP and all the modern APLs have, then you can do more intuitive things when you're just scanning left to right instead of doing this quadratic thing. And also there's the performance implications, which I care less about, but if you're actually using it as a serious language, you would. Anyway, so now in the beta and soon to be .12 release, we've got the 2 slashes, but the 2 slashes are what correspond to left and right reduce. And actually, I used to think visually in my head that the slash, if you think about a slash moving across a list of numbers from left to right, the reduce ends up kind of eating the numbers because it gets caught underneath what would be like the equivalent of like a snowplow. And for the scan, it ends up being like a ramp. So you end up like the numbers pop over and land. That's how I always used to visualize, even though technically that breaks because of the way that they're processed. But if you consider them to be, a left fold and a left scan, you kind of have this visualization. You have to stretch your brain a little bit for like the reduce to be eating the numbers and the scan to be popping them over. But what's interesting about this is this still technically follows that pattern because one's reducing from the left, one's reducing from the right. So both of them are eating the numbers dependent on the direction that they correspond to. So that's very cool. All right, so we popped that question not very quickly off the stack, but it was good to dive into it. Should we go back to the Omnibar? Because now I want to play around with this live. I'm trying to think. Like, I think outer product might be actually the least agreed upon glyph, and it would be even more clear like if BQN and Uiua were there and TinyAPL, because that would introduce 2 more glyphs to the screen. What actually is extended dialogue? APL has added the slash to be outer product as well?
Dyadically, it's the table. I asked why it was like that. I can't remember now. It didn't click with me, but I guess the point was having the dot thing is not great. It's not a normal primitive. It doesn't act like a normal primitive.
Yeah.
So I guess it was just free. I don't know. There is some explanation, but I can't remember it.
And so wait, how does, because slash already corresponds to scan, but you're saying when you combine that with a binary operation or a dyadic operation, as I assume what the D stands for, that only actually creates a monadically defined verb, and so therefore the dyadic definition is still up for grabs. Is that how this works?
Yeah.
So you're basically able to use the dyadic definition of the verb formed by the slash operator in dialog APL. Interesting. I mean, I like that they have assigned a glyph. I'm not sure. I guess APL, dialog APL specifically, they're kind of adding, they're glyph adding a verse. Although I'm not sure how. I'll have to ask Adam about that next time. And interesting, Zyma uses the we'll call it target glyph, which is what BQN uses for under.
Yeah, and extended uses for the combining a real number and another real number to make a complex number. If I can look up the glyph, I think.
Can you look? Oh my goodness, that's amazing! Oh my goodness, this is phenomenal. This is such a yeah. I implore the viewer or the listener to really go check out Omnibar. I tweeted about this, just talking about how amazing of a project it was. Before I knew about the multiple search functionalities. So you can search, the name of a glyph. You can search the glyph itself. Oh, so let's have fun. I mean, what is another glyph that across languages has, like, I guess like Enclose. I'm trying to think. Although Enclose. Yeah, what's like the most overloaded glyph that has different definitions in each of the languages? So I mean, if you search Enclose again and then grab the shoe from APL, and then paste that in there. Yeah, so something like this. Yeah, I mean, I'm gonna have fun with this afterwards. But so this has 1, 2, 3, 4, 5, 6, 7 different definitions. Enclose, partition, duplicate, commute. I didn't know about those ones though. From SAX, an APL. What does SAX stand for? It just stands for SAX.
I think it's Sharp APL for Unix or something like that.
Oh wow.
It's an old thing. Compiling this list was a bit hard because there was a lot of like old APLs with documentation that's like one big PDF file that's not on the internet anymore. So I had to look around a bunch. Adam helped me out a lot he sent me some documentation pages for things that I didn't have access to.
Yeah, I mean, no, it is how do you pronounce this word? Herculean task? That might be mispronounced. But yeah, I mean, it reminds me a little bit of my unpublished website, Google Translate, which is you might think, oh, it like crawls the web, and it's like, no. Whenever every single function and language that you see in one of those images is like hand pulled. And the idea was to release it and open source it so that, if some Zig fan comes along and wants Zig to show up on it, they can go and just contribute and have a README that says, all right, I'm very curious. We'll only spend a couple more minutes. What happens if you type in last? Is it most missed primitive? Ooh, only one language, which is DVI, which stands for Dialog APL Vision, has. So that's not even like an actual APL. It's it's the aspirational direction. What is wrong? I mean, does TinyAPL
TinyAPL has last.
Okay, well, see, that is. I mean, if there wasn't a sign from above that you need to add TinyAPL to this, it's that right there. Because what is the last operator in TinyAPL? Also, too, I just saw an emoji from the chat. Feel free to ask questions if folks have questions as well. I mean, if you're listening to this in the audio version, you can ping us on the socials and ask after the fact. But yes, what's the last in TinyAPL, and why is it missing from every array language?
Yeah, it's the same thing. It's like in Vision. It's I guess it is a very recent idea. I don't know. It seems pretty intuitive to have. You have first, why don't you have last? But maybe nobody thought of it. It is really simple to get because you can just, if I have a matrix 1, 2, and 3, 4, and if I do last, it gives me the last element. So it just first, and then you reverse, and then, you reverse, but you have to arrival first. So it just three glyphs. So maybe they thought it wasn't, useful enough to have the primitive. I don't know.
I'm trying to think too. Is that glyph? That glyph doesn't even. Did it have to be added? Because I know partition exists in Dialog APL, and so yeah, it doesn't look like it. It doesn't exist. So that glyph is just waiting. It's glaringly waiting to be added as a not symmetric but pretty close. So this is the. I don't actually how you call these. It's the shoe with the opening, the shoe being the sideways kind of U, which is similar to, I guess, first. And it's the vertically flipped partition from Dialog APL, which is also a primitive that I miss in BQN many times. And yeah, so and that was the thing. At first I was like, oh, does that make sense? But then I forgot that first in Dialog APL is just the ununderbarred version of this. So you do, if we want, we can go back to the interpreter and we can build up a fork that is the first and last of a list, which, it's going to be shoe. Oh, have you added? All right, now we're switching topics again, folks. So I was expecting to see, does the name of the glyph, the crescent, does that have a name, or how do you refer to that?
Yeah, I called that. Actually, I don't know. I don't have an official name for it yet. Okay. You can, crescent works. So sometimes I call them white moons.
Sorry, white moons?
Yeah, because they look like little half moons.
Oh, yeah. We'll call them, sure.
For the audio listeners, it's the round bracket with a pipe in the middle, so it's like double stroked, I guess.
Yeah, so it's like a parentheses with a line joining the 2 points. Kind of looks like a bow for a bow and arrow. I guess we could also call it bow. Maybe we'll call it bow. Well, we'll stick with white moon because that's what you've been calling it. Anyways, you've got 2 white moons, and then typically you, in order to create a fork, you'll put your 3 primitives with diamonds in between. But Madeline just typed it out without the diamonds, which I think you had alluded to when we were chatting leading up to this, that you have is it called dense notation? Or what was the notation for these new... So we're going to the trains documentation page. And maybe this is
I
a
call
good
them
point. We spent a long time
trains.
sorry, go ahead.
I call them compact trains.
Compact trains. And so, yeah, introduce these to so for folks that have been looking at TinyAPL in the past. This is something that is only in the beta and is going to drop in .12. So yeah, walk us through how this works.
Yeah, so the old syntax is just, I'm going back to my usual example, which is sum minus product. 2, 4. Okay, so usually, yeah, it used to be that, in dialog, if you want to make a for that is like the difference between the sum of two arguments and the product of two arguments, you just write, open parentheses plus minus times, I guess, plus minus times. I don't really like this syntax because it's not very generic. I guess this is the problem, because if you want to do like 10 minus the factorial or something, this doesn't work obviously, but you can write the train 10 minus factorial. But if you want to do the other way, so factorial minus 10, you can't write that because factorial minus 10 is function application. So what I did originally was to add this moon syntax. So this is the train syntax. So basically, you put all of the tines of the train in these moons. So open moon, and then the first tine and diamond between each tine, and then at the end to close the moon. This allows for the more generic thing. So you can write factorial minus 10 of 4, and that works correctly. It is very verbose though. So recently I decided that I wanted to do a shorter way of doing it. And of course there is the fork operators, but those are a bit annoying when you want to write longer trains. So I did compact trains, which are basically inside these white parentheses, the moons. You have a special syntax where function application doesn't exist anymore. So if I write factorial minus 10, it doesn't parse as factorial on minus on 10, so it's just an array result. It parses as three different trees which are not linked together. So then the train syntax makes them become a train. So in most cases you can just omit the diamonds. But if you want to have function application, you have to add brackets or to keep the diamonds. So if I want to do factorial minus 10 plus 5, here I don't need the brackets if I use the diamonds, because the diamonds already separate expressions, right? But if I do the compact train syntax, this is not going to work anymore. Oh, sure it does. It usually doesn't work anymore. I guess in this specific case it still does. But so you have to wrap it in brackets for it to work. So it's more compact in some cases, it's more verbose in other, but in general it becomes shorter. And if the train is not too complex to read, it gives you less things to think about. So I think it's better from a conceptual standpoint as well.
This is this is I think in a lot of cases a drastic improvement, because that was one of the comments on the PR I put, is that a lot of the times when you're going from an explicit expression to a tacit expression in TinyAPL, a lot of times it can end up getting longer, because in a simple explicit expression, you might end up going from 2 braces and an omega, similar to dialog APL or cap for a function, to 2 white moons and then like a number of I think you called them train operators. And now with, at least for the simple cases, if it's just following one of the basic patterns, you can delete those. It now basically corresponds, I guess never in the case where if you have an expression in cap or dialog APL that doesn't need parentheses at all and just happens to fall into an end train pattern that doesn't require parentheses. TinyAPL Apple will always end up being longer because you at least need a minimum of two of the white moon, the white moons. But in certain cases where you need a parentheses or you need a set of parentheses, it could end up being equivalent. And also, too, I did not actually ever understand until you just said why the opposite of what they call in dialog APL an AGH fork, where G and H are your functions and A is an array. I mean, we've talked about it on ArrayCast, but I never actually understood that the reason you couldn't have an FGA fork is because it reads that, and that's like a valid expression. So it's syntax. It's a syntax space that's already been used by just like regularly evaluating the expression, whereas 10 or like AGH, that is not a valid APL expression. So then they can, and that was kind of the curious thing. If you think about, that up until a certain point, trains didn't really exist in APLs. And then they realized that like without an array on the right-hand side of your expression, that's not valid APL. So we can use that space to introduce all this tacit stuff in the case where you don't have something on the right. But this is the exact reason that you can't have that FGA fork, which, if you understand that, it actually does lend more motivation to the design choice that you used, because now you can write something that is not possible to write in the existing APLs, which is very interesting. Yeah. So, I mean, should we talk about, we talked about this a little bit on the Array cast episode, number 88. Link, once again, in the description/show notes. And you have, inside of this syntax, a ton more that you can do that I believe you've borrowed from J, which are the not just the verb trains, which is what we classically think about when we are doing tacit programming in J or dialog APL, but also the modifier trains, which I, in my coding in TinyAPL, did not actually program any of these. But yeah, maybe you can walk us through the proliferation of patterns that are here. And, if you ever actually use these, I know it's kind of more of a for fun thing, but like how often do you actually find yourself reaching for these quote unquote modifier trains?
Yeah, I'm trying to find an example of where I use them. Yeah, it's a bit small. So this is a solution from Advent of Code. You had to parse a string. So basically, I built a whole parser combinator library just for that. It's very slow. It took about an hour to solve the problem, but it was fun, so I kept it. So you can see here, this, and copy it into the interpreter so it gets color. This is a conjunction fork, conjunction train. So basically what I'm doing is actually can remove this bit. So basically I'm saying I take two, this is a conjunction that takes, so a dyadic operator that takes two functions. So it applies first to the right time. So it does f after g, and you can try it. So this is fg, right? So it becomes f after g, f after g, okay? And then it does map, so composing basically, which is just another conjunction I defined. So it becomes last, which is a normal function, combined with the result of the other conjunction. So it's just a shorter way to write a defin that just does this, right? So, sorry. This is the explicit version. This does actually work because you still have to pass the arguments, but that's just an annoying thing. I'm going to change it soon. So this what I'm writing right now is just a normal defun, which is a conjunction. So I call this conjunction after with the two operands, and then I call map, and then I call last. I just pass last as the other operand. So this conjunction train is a shorter way to write that. So yeah, it just combines conjunctions and adverbs and functions just like you would normal verbs in normal train. There is a lot of rules. You can see them in the documentation page. I think used most, of course, but a few are useful sometimes, so I kept them in there. I added them just because I wanted to try them out and see if they were useful, and they found that sometimes they are, so I kept them, I guess.
Yeah, it is. I mean, it's a world that I have wanted to get more into. Like I said, not necessarily for the practical uh, or usefulness of them, but it is, I think, a less explored space. I mean, famously, Jay had it at one point, then they got rid of it, then they brought it back. Um, and it's neat to see that, yeah, you're actually using them. So that with that pattern, is that one of the more useful ones? Like you said, you use a couple of them. What would you say are the most useful patterns of these that you find yourself reaching for?
I think the one that I use the most is conjunction, 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 which is this last one. So it just applies the two conjunctions on the end to both of the operands and then passes the result to the middle conjunction. That's probably the most useful, I think.
Okay, so this is like just the modifier version of the dyadic fork. Or is it dyadic or is it monadic?
Yeah, it's dyadic in the number of operands, I guess.
Right. Very interesting. I mean, so maybe this is a good point to like you've built TinyAPL and you've tried to put all of the features into it. What have your takeaways been from? I mean, and I know you're not finished. You're actively developing it, but you said it's kind of like a design exploration space for if everything was you could reach for every single tool or primitive across the languages. It'll give you the ability to figure out what are the useful things, what are the less useful things, what have your takeaways been in kind of designing this language, and maybe from there we can transition to talking about what might be an upcoming project that you mentioned to me before this.
Well, the main takeaway is that language design is hard. There's a lot of decisions to make, and I haven't done all of the right ones, and I'm trying to change that. Every new release, I make a few breaking changes to try and get it to something that's I think can be more useful to the user, which is mostly me, of course. But there's a couple people who have used TinyAPL before.
Including me.
Yeah, I wanted to make a useful tool for reasoning about things. It's the notation is a tool of thought thing. It's just a lot of notation, I guess. Many primitives to choose from means that you can express more clearly what you're trying to find out, or trying to mean.
Yeah, I mean, I think I said this on a Raycast as well, that if I ever had my ideal language, array language. Well, I mean, it's implicit that my ideal language is an array language. Says the person with multiple like array language podcasts. I actually probably would lean towards having more primitives. Like I know that BQN, due to Marshall's desire to have a I believe the word that I've heard Marshall use is solid. There was a discussion when Kai was on, Kai Schmidt, the creator of Uiua, about the differences of opinion on whether indices or where should work on greater than rank 1 arrays, where it's giving you the indexes corresponding to Boolean values. I believe TinyAPL and Uiua, they will give you a result for that, but BQN does not. And Marshall's reason is that he wants it to be super solid, and it's go listen to that episode. It's basically less principled because you get back different types depending on the rank of your array. I tend to agree more with Kai when it comes to this. That yes, it's less principled. I understand that argument. However, it is very useful in a lot of cases to have primitives that have different behavior and that do things that are practically useful, even if not entirely principled. And I feel like that extends to glyphs as well. Marshall wants only the primitives that are these kind of, he has a whole page on it that talks about these, they're kind of fundamental, and they don't have, there's not 6 different flavors of it, which could be, a set of functions. Like chunking algorithms are a great example of that, which is why he hasn't put the partitions in. All this to be said is I love the fact that in TinyAPL, you have everything. You have more than everything. You have things that, like, I think rank was one of the glyphs that I came across. Every single APL spells rank as just like the shape of the shape. But in TinyAPL, you actually have a rank glyph. Would I ever make use of this rank glyph? I don't know. But the point being is that when you can reach for something, it's kind of got like the jelly feel to it. I'm not sure if you've done any jelly programming, but like jelly has like everything you could possibly want. Increment 1, decrement 1, half, double, things that are spellable in 2 characters in most array languages. Or you've, look at this. I didn't actually realize you've got increment 1, and then and you've got decrement. Ooh, that's not a double dash. That's just a split hyphen. So it's a single operator or single glyph.
Yes, it's a single glyph. I'm not sure what Unicode calls it. Let's see. It's apparently a letter from some random alphabet I had no idea about.
Tiffin letter yo. Well, I've never heard of that before, but anyways, I love that there's like I was talking about the things that are on my top 4 or 5 things from Dialog APL that irritate me. One of those top things, along with the broken scan, is the missing sorts. I mean, how do you not have a sort? Even finally, I think Kai, I'm not sure if it's still in experimental or it's come out of experimental. Oh yeah, look, we've gone back to Omnibar. So yeah, and you chose the enclose, like the triangle underbar, correct? In Tiny.
Yes, because I have these comparisons with a vertical bar, which are basically the comparison equivalents of match and not match. So basically, equals tell you if each scalar in an array is equal to another, but match tells you if the whole array is equal to another. And these primitives, which are called precedes and succeeds, basically tell you is the whole array bigger or smaller than the other one. So the choice behind using less than or equals to for sort in dialog vision is that if you have a vector and you sort it, the relationship between the consecutive pairs, the adjacent pairs of the result, is that they are less or equal to each other. But if it's a higher rank array, of course, less than or equal compares scalarly. It doesn't compare the cells. So I chose to use the compare a whole array glyph, so the less than or equal to but the whole array, because for higher ranks, it still makes sense that you can build the pairs and then compare them and see that they're like this. So.
Yeah, we love it. Honestly, it actually didn't take me any time to find it, because as soon as you go to the primitive page, if you search for sort, it comes up, which is very nice. There was one primitive. Oh yeah, unique mask. I thought you didn't have unique mask for a bit, but that's just because on the primitive page it's called nub and nub civ, which are the names taken from the J language, another J inspiration. So that I think that was. Sorry?
Doesn't Dialog also call them nub civ?
Do they?
Oh no, they don't. Okay, I thought it did.
Well, yeah, I couldn't remember. I wouldn't have been surprised if it had been, but I do recall when Adam presented, I believe it was Dialog 18.0, there was a webinar on YouTube, and at least colloquially, when he introduced it in his presentation, he called it unique mask, but the documentation sometimes differs from what it's actually called. I mean, what is it? The squiggly diaresis double dot. People refer to that as selfie or self. And it also has two different meanings technically. Yeah, commute and swap. So I never. Yeah. I guess that one probably religiously is called. What happens if you plug that into Omnibar? Both the symbol and the name swap or commute.
The names in Omnibar are normalized, I guess. So if two different dialects call it two different things, but they do the same thing, I just pick one. So yeah, they're not separated, I guess. It's just one name per meaning, even if they're called different things. So if I go to, I call it nubc, even if some dialects call it unique mask. I think you can type unique mask. Unique mask, it still comes up because I added like an alias. So yeah, but it just shows a single name, even if it's called different things.
Yeah, very cool. Very cool. Anyways, there was to get back to my my point that I was making is I love the fact that TinyAPL has a bunch of primitives, and I think if I ever designed a language, I would have like a bunch of things that don't exist in any array languages that like maybe performance wise, they aren't great, but they're still just very, very useful. Like there's a lot of like combinatorics functions that are not useful like every day, but when you do want them, if you go to the bacon crate or any of those things and you look for power set or combinations or permutations and all this kind of stuff, like writing that stuff out is non-trivial, and I would rather just be able to reach for a glyph, and like there's a glyph that I actually think that a lot of so you are able to spell this in TinyAPL with the, I believe, prefixes where you have like a two-wise reduction. And like that's kind of something that's spellable differently in a lot, like TinyAPL and CAP, they have the n-wise reduction. You've got like the n-wise prefixes. If you pass that a reduction, Uiua and BQN, you have to do the windows or stenciling and then reduce over the rows of that. I think that like the specific two-wise reduce is so common that should have a primitive by itself. Like in Q, there are both differ and deltas, which are basically specializations of the two-wise reduce, and they have a keyword for two-wise reduce, which is prior. So they've got prior, which is a two-wise reduce, and then two different specializations of prior, differ and deltas. You're showing me here in Uiua now that they're... what are we doing here?
This is the new stencil operator. So if you pass it a dyadic function, it just applies it to each pair.
No way. Are you serious?
Yeah.
Wow. Watch this. You're plugging... This is... So here I am whining about the state of array languages when it comes to two-wise reductions. And now you're telling me... And I guess this is only possible in a language without ambivalence because it needs to be able to dispatch on the arity of the operation. Wow. Kai's secretly, like, it's a covert operation for him. He's trying to pull me to the stack side of the array languages. What is ++?
Oh, it's just showing that it works for more than dyadic functions as well. If you call it with this is a triadic function, I guess. So it applies to each traitlet of the argument.
It applies to... So this is 3? So this is no longer a two-wise reduction, it's a three-wise reduction?
Yeah.
Holy smokes, what was that? What's going on there? We got the...
This is...
The colors of some flag, or what is that?
Yeah, I think this is the poly flag because it's a couple with more than two things. But yeah, this is a subscript. Subscript couple. It takes n things from the stack and puts them in an array. It's like a generalization of solo and couple from BQN.
Kai's having way too much fun with his coloring of his primitives. Wow. That's amazing. Well, so the question is, does TinyAPL have anything, or is it the spelling that I think we had talked about that. It's the dyadic operation fold prefixes, which is how J spells it as well.
Yeah, it's like this. Well, I guess it's because it's Uiua, it's going to be the other way, so like this.
Wow. I mean, so this is still, in my opinion, how would I rank actually the length? This is still better than BQN, and I was going to say Uiua, but not Uiua anymore. So now I guess I have to rank, if I'm going to rank the array languages by, we'll say n-wise reductions. We won't be specific to 2. I guess Uiua has to be number 1 now. Then number 2, tied for number 2 would be Dialog APL and cap, because it's one less glyph. You don't need to specify the 2 glyphs. And then it would be TinyAPL, then followed by J probably. Or actually J, I guess each of the glyphs in J are just the 2 slashes. That being said, for a lot of the binary operations, it's going to require 2 ASCII characters. I guess, I shouldn't say glyph in J because J does not use glyphs. And then after that would be BQN in last place, which breaks my heart because I do love BQN, but it is rather cumbersome to have to do 2 windows and then binary operation reduction over cells is it's just so cumbersome trying to spell that for what is such a common operation. So yeah, now Madeline is typing BQN. We're just going through, we're speed running all the array languages now. Oh yeah, look at that. The very nice windows next to iota, which share the same glyph. So you end up with the 2 double-sided arrows. And then yeah, minus.
No. It's
technically
cells,
it's
right?
minus fold cells if you want to do it. Yeah, like that. So yeah, this is 1, 2, 3, 4, 5. Which I guess is that what was right above BQN. Yeah, so it still is shorter in TinyAPL. Anyways, we're gonna have to have Kai back on the pod. Which pod? Well, I'll just bring him back on Tacit Talk because we already talked about the subscript operators that he added. But now he's got Stencil, the operator that I guess maybe he knew I wanted it. But anyways, it's there now because it's a very useful thing. Differ deltas from and prior. I was saying we were going to use this as a transitioning point to future projects, but then I just remembered in the last 10 minutes that I also wanted to talk about the choice of implementation language and how that's affected things. So for those that don't know, let's go through all the languages. So we've got Dialog APL and BQN, which are both implemented primarily. The main implementation is primarily implemented in C. Also C++ for Dialog APL and Singeli for CBQN. Then Uiua is implemented in Rust. Cap is implemented in Kotlin. And now TinyAPL is implemented in Haskell. I don't actually know if there has been a glyph-based array language, Iversonian array language, that's been implemented in Haskell before. So we've got Haskell, we've got Rust, we've got Kotlin, we've got C, and then as additional languages, C++ and Singeli. What made you want to choose Haskell? And if there's a bit of a backstory behind that, feel free to share it. And how has that affected implementing this language?
The original choice was just because I wanted to learn more Haskell. I did like a beginner's course, but I found it really interesting, so I wanted to learn more about it. And yeah, it's worked. I know a lot more Haskell now. If I look back to some of the code that I wrote in the first parts, it sounds great, I guess. So I fix it, and routinely I just found new code that old code, I guess, which is not what I would write anymore. So it's not ever been a problem, not having mutation and stuff like that. I haven't really found the problem with that, except in the last couple of days when implementing mask. Mask is a primitive from Uiua, which just marks you. It shows you. It gives a number to each position of a subarray in a bigger array, and then it marks the whole list. And this is the first time that I actually wanted to have mutability and stuff, because I wanted to keep like a variable that told me how many times I had found it before. So I had to work around that. But yeah, I'd never been a problem before, and it's actually really fun writing Haskell. It's a good language. I think you can easily express what you want.
How did you find your way to Haskell? Had you just taken a course? You'd heard about it online, or
Yeah, I think I found a course that was free and taking a few people, so I enrolled, and they accepted me. So I learned it mostly through that. Yeah.
Interesting.
I
Yeah,
have also always been interested in functional languages, so I always wanted to learn Haskell. I just thought it was a bit too hard, but then I found the course and it helped me a lot.
Yeah, no, I love Haskell too. It's I have not written any production Haskell, but before I fell in love with array languages, Haskell was my favorite language. Honestly, it's very. But there was a comment I got on a YouTube video once that said that J is just compressed Haskell or something like that, or Haskell is decompressed J. Which for some definition of the word decompress or compress is kind of true, right? You don't have the rank polymorphism in Haskell, but the idea that you're kind of doing this collection-oriented programming where you're reaching for primitives and then just kind of composing them together. I mean, how often do you find yourself writing actual recursive implementations from scratch versus you're just reaching for something in the prelude or some data.list or some other library? Like, what would you say the split is? Is it 50-50? Is it 95-5? Or what would you say about that?
I don't know. I feel like I do write a lot of manual recursion, but it's mostly because I don't know how to use folds and stuff. Especially scans and unfolds and things like that. I know how they work, but they just don't come up to me as the first thing. So I prefer writing manual recursion for that. So I think I have a lot of recursion, but probably most of it could be replaced by a complex call to unfold or to scan or things like that.
Well, maybe that's I'm not sure if you're open to contributions, but if there's anybody listening or watching that is a Haskell enthusiast and is looking to contribute to some open source thing, maybe that would be a cool project to do, is to go through the source code. I mean, my favorite thing to do with C++ code is find what they call raw loops and then just be like, oh, that 5 lines of code maps to a single call to some algorithm, stood partition or something like that. And then the refactoring is just going in and deleting the code, inserting the algorithm, and then you open a pull request and it's negative 90 lines and net. And so it's just deleting code. And that could be a fun project even if you're not a Haskell pro and you want. What are we looking at here? This is a group.
Yeah, this is a recursive function. So basically I just iterate over each of the left arguments, and I keep a list of the result as another argument. So this is probably going to be able to be written as a scan. I don't know. Or maybe enough. I think a fold would work here. But yeah, just more natural for me to just write a go pattern, so an inner recursive function that it gets called by the actual outside function.
What is you have prelude.max? Why is that necessary that you have to prefix the max function?
Because there is my own max function, which is the APL primitive max.
I see. Interesting. Very cool. I mean, it's very cool that there is an array language out in the wild now that's implemented in Haskell. I always find when that list of languages grows, what will be the next language that the next APL will be implemented in. Speaking of the next APL, you mentioned to me before recording this that you had plans for potentially a new programming language. Maybe you can. So this doesn't, as far as I'm aware, exist yet. This is just a plan documentation or a roadmap documentation. So walk us through this kind of, I guess, announcement, as probably not too many folks know about it. And what's going on?
Yeah, this is a very early draft of a new language which I called Strawberry. The name was suggested to me by somebody I know, and I really liked it. It was originally a suggestion for renaming TinyAPL directly, but I just used the name for the new language. The main concept is that it's not an Iversonian language, not the APL syntax, but it's like the direct opposite. It's sometimes it's called an LPA syntax. So it's like left to right, it's reversed APL. I'm trying to find the examples now. So, this is in dialog, you write the square root composed with the sum over the square. So this is reversed, right? So you write the square over the summation composed with the square root. But then another concept is that there are any argument functions, a bit like in K, but I don't really know K, so it's not a direct inspiration. Just know that it's a thing it does. So, I did my own version of it. So you can see here, length is a function, and then I'm calling it with 3 arguments. So this is not an array, it's not a list. It's a call with 3 arguments. This allows for a lot of interesting patterns, I guess.
Can you just zoom in a tiny bit?
Yeah, sorry.
Just so that we can make this. Yeah, okay. That's perfect.
But the main thing is that there is an interesting syntax for forks or trains, because there is a syntax where you use square brackets before a function to pass it as many arguments as you want. What happens if you pass functions to it? Well, what they decided will happen is it makes a train. So this first line here is, I'm going to write it out for the audio listeners. It's the call, so open square bracket with the reduction sum and comma, the length, and then close call, and then the divide diff. So what it does, it just builds a fork. It's like if you wrote, sum reduction divided by length in dialog APL. So if you call a function with other functions, it builds a train. There's also modifier trains, I guess. So the modifiers also support this linearity call syntax. Let's see if I have. Yeah. Choose here is a modifier, and then calling with 3 parameters, 3 operands. And if you pass modifiers inside here, it makes a modifier train. So it's even more natural. It's an even more natural extension than the one in TinyAPL, where you just passing modifiers inside the train syntax. Here it's just a very direct extension of how call already works. These are the main concepts. I think they're pretty interesting. It's very early draft again, so there are many things that will change most likely. If I just go, there's not many primitives planned for now. More the most interesting ones aren't there yet. There's a lot of work to do, but I think it can become something that's very interesting.
So first comment, love the name. I think my preference for names, which is very hard because there's only a limited number of emojis that look cool, but any name that maps, that's actually why I called the fork of jelly jellyfish, is because there is an emoji for a jellyfish. I love the idea of any project that you name, whether it's a language or something else, if it's going to be public facing at some point, if it maps to an emoji, that's amazing, and you've nailed it out of the park with that. My second question, well, I guess first question, the first one was a comment. Are you familiar with, and because I am not really, and if the answer is no, maybe we can try and figure out what it is. Are you familiar with atlases from Nial?
I know they exist.
Yeah. And the reason I ask is
It's like function arrays, is it not?
yeah, something like that. I think you're gonna have to. Yeah, there we go. And then there's a website. At least the last time I checked.
Uh,
Or if you go back, I think that the APL wiki will link to the Niao website on the side there. Documentation maybe or website, yeah, one of the two. And yeah, if we find atlases here, yeah, there we go. An atlas is an operation made up of a list of component operations. The result of applying an atlas is a list of the same length as the atlas. Each operation in the atlas is applied in turn to the argument, resulting in an array value that becomes the item. Yeah, so that's why because when you showed the example of the average, it was basically a list of sum with length and then a postfixed division. And I'm pretty sure that I've seen Niao code that looks somewhat similar to this. And so is that basically what this is doing? Is that it is creating, or probably not, because that's more like stack oriented. So how does the evaluation of this work? Does it create like a list of two things that then gets applied to division, or is it just creates like this pattern always has to be followed by a binary operation?
Yes, the square brackets indicate function calls. So you can see here, when I write open square bracket 2 and then 3 and then 6 and then close square bracket and then length, I'm not building a list and passing it to length. I am just passing 3 arguments, right? So here I am passing 2 arguments to divide, but these 2 arguments are functions, so it becomes a train, a fork. So yeah, you can't just write square brackets without something after that, because it's like incomplete syntax, I guess.
Okay, yeah. Jacob, I'm not sure if you know Jacob in the chat, yeah. But seems to be
is the other TinyAPL user I have.
I was going to say, seems to have a familiarity with the syntax of saying all inputs are passed through each function in the square brackets, and then that list is passed as the variadic argument list to the function after. So if we look at length, length is power. So yeah, walk us through what the length function actually is computing. There's a square root, a plus, a power, and then it looks like 2 composition operators, but I could be wrong about that.
Yes. So modifiers are also swapped from normal APL because the execution of things is in the other way. So this is saying we can start from the end. This is the square root, but before it's a composition, before we do sum, but we do over, like in QN, over monadic star here is squaring, not the
squaring.
So so it is squaring all of the arguments to a sum, and then they're passed in the square root. So if I just do it diagonally, it does, I pass it 3 and 4, so it does 3 squared and 4 squared, which is 9 and 16. It functions and it becomes 25, and I take the square root and it's 5. If we pass 3 arguments, it does the square of all of them. So 2 squared is 4, 3 squared is 9, 6 squared is 36. And then it passes the 3 arguments to the sum function, which when you pass any arguments that are more than 2, it just sums all of them. So this is just summing the 3 squares, you get 49, and then you take the square root and you get 7.
I'm just thinking. So at first, when I heard you explaining this, the plus operation that follows the over combinator, I'm not sure if that's what you're calling it, aka the psi combinator, my first thought was, oh wow, the psi combinator or over, this is actually an implementation of it that corresponds to the variadic version, because when it was introduced back in the 30s or 40s by Haskell Curry, technically you can think of over, like there are 2 different combinators. Actually, there's a couple of them, but the 2 outside of trains are over and a top, B1, where you can think of, they exist in Dialog APL. Over is a unary function applied to two arguments, and then those pass to a binary. But you could technically extend that to any number of arguments. You could apply that unary operation to, 100 arguments, and then as long as the arity of your function afterwards matches that of the number of arguments, you're good to go. But I don't think that's exactly what's happening here. You're saying that it's special behavior that maybe, is it just for plus, or is it for any binary operation it applies that to a reduction, like similar to over, or not over in the combinator sense, but over, like when they talk about reducing, they say, oh, we put plus over all these arguments, but we'll call it a fold and stop overloading this.
No, you can see here, this is documentation for over, which is called to all, because it applies the function to all of the arguments. The lowercase letters here are the arguments, and the uppercase letters are the operands. So you can see in the case where you pass 3 arguments, so a triadic call, this is calling the second function with the first argument the first function applied to the first argument, the first function applied to the second argument, and the first argument the first function applied to the third argument. And if I go into the documentation, B here is plus in this case. So if I go to the documentation of plus, which I think I called sum increment, you can see that in the triadic case, it takes 3 arguments, of course, and it just returns the sum of the 3 of them. So if you, most functions like multiplication and power and things, if you pass more than 2 things, they just do an implicit reduction, I guess, but it's not really a reduction because you're not passing an array, you're just passing more arguments. But you could have, for sure, a custom function that if you pass 2 arguments, it does something, and you pass 3 arguments, it does something else. If you do over and you pass the 3 arguments, it's going to call the triadic version of the inner function. So over, just like in TinyAPL, I guess, calls one function to each argument, and then calls the other function with the result of all of those. It's just that in APL, you can pass at most 2, and here you can pass as many as you want.
So does this behavior that sum has, is this when a user is implementing their own function, do they specify all these behaviors, or is this kind of a built into any dyadic operation when called on a triadic call or more has this behavior? So like because what I'm thinking is that there's technically in array languages, we'll stick with Dialog APL or TinyAPL for that matter, if you have a fold or a reduce, you have your binary operations that make sense, plus, times, etc. Technically, there's nothing preventing you from doing a rotate reduction, though. And you can actually take a list and do that. It doesn't make a ton of sense, and you're probably just going to end up with some single value at the end that doesn't do much. And so I guess that's my question, is that could you, if you called a rotate at the end of this triadic call, is it going to have this triadic call behavior, or this is like it's function dependent?
No, it's function dependent. Yeah, each function defines what it happens when you call it with more than 2 arguments. It's a bit like in BQN. You can write headers. So you write, self right. A, and you say what happens when it's a monad, and you say A self B, and you say what happens when it's a dyad. Here you can do the same thing with case syntax. Let's see if I can find it easily. Yeah, cases. So you say if it's a call with no arguments, I return something. If it's a call with 1 argument, I return something else. If it's a call with 2 arguments and 3 arguments, etc. So yeah, each function defines what happens with each arity. It's not an implicit reduction in any case. It's just that for some specific functions like sum, the natural thing to do is just to sum all the arguments, right? So if I say plus called with 1, 2, 3, the only thing that makes sense is to sum all 3 of them, right? So that's what it does.
Interesting. Very interesting. I mean, I actually don't know what I was hoping for, but this makes a lot of sense. And yeah, it kind of is nice that you can do that for the binary operations that make sense, you don't actually need to specify the reduction. I've always kind of thought that there's, 4 primary operations. There's folds, there's maps, there's scans, and I think outer product is the 4th. But in APL and in array languages, we kind of make the map. We make one of the 4 operations implicit, invisible. And there are certain Lisps that actually do the same for folds, where if you pass a binary operation like plus to a list, it just implicitly says, oh, you're giving me a list with a plus. Obviously, you want to sum this up. And this is kind of the same, a little bit. Like it's user defined, and I guess it'll also be primitive, or I guess language implementer. So you defined for the built-ins. And my guess is that that gives you actually kind of the best of both worlds. You're going to end up with the rank polymorphism where maps are implicit, but then in certain cases for reductions, you're also going to get the fold implicit, which is, I never thought that you could have both in a single language, which is very cool. Yeah. So, I mean, what are your goals with Strawberries? I mean, because you're already working on TinyAPL. Is your goal to work on these in tandem? Are you going to transition from kind of working on TinyAPL to focusing on Strawberry?
I for sure want to finish TinyAPL version 1. I have all the features that I planned originally. Okay, that's not really true. I keep adding new things I want to implement. But eventually I'm going to be done. And I think I will have already started working on Strawberry by then. But yeah, the idea for now is just to work on both of them. For a long time, Strawberry will just be, writing specification for all the primitives, figuring out what each of them should do if you pass more than 2 arguments, because it's a mostly novel thing, right? So there's a lot of space to explore there. So yeah, the idea is just to work on them both at the same time. I will try to not take too much time away from TinyAPL, which is it's really interesting to work on, but sometimes I want to think about something that's completely different, like Strawberry is.
Yeah, this is very cool, and really cool that you're going to be working on both going forward. I mean, we're getting close towards the end of time. I want to throw it over to you. Is there any final things you want to talk about, or things you want to plug? I mean, I think we've talked about all of your 2 biggest projects, Omnibar and TinyAPL, and an upcoming project. But yeah, I mean, I'll throw it to you. Also, we've got several, or we've got a double-digit number of people that are watching live. If there's questions in the chat, now's the good time to ask as well. But yeah, I'll throw it over to you. Anything that you want to plug, or things we didn't talk about that you wanted to chat about, yeah, the ball is in your court.
Yeah, there's this really interesting thing that I added recently, which I think might take too long to explain fully. But it's called extra arguments, and basically it's a way to pass I'll just explain. It's like configuration parameters to all functions. You can do it to primitives, and you can do it to user functions as well. So let's see if I have an example here. Yeah, so here I'm just calling a function f, and I'm specifying extra arguments, which are keyword pairs. So it's key value pairs. So the key here is a, and the value is 3. And then you can access them if it's a default, and if it's a primitive, there's a set that like modifies what things do. So for example, the most interesting one is fill. So if you have, if I do mix on 1, 2, 1, 2, and 3, 4, 5, something like that.
Oh, I know exactly where you're going with this. This is like,
yeah, it's everything. This doesn't work, right? Because you're trying to put together a 2 vector and 3 vector. That doesn't work. But I can do fill 10, and it adds 10. There's also shorthand modifiers, which are like just a shorter way to say the same thing. So I can use the fill modifier, which is just sets these extra argument the same way you would. So yeah, in defense you can access them with the epsilon keyword, I guess. So if I pass hello world, sorry, I have to call it, of course. I pass it 10. it's a dictionary, it contains the key hello and the value word. So yeah, I can do lots of things like that. The index one thing I showed at the beginning is just an extra argument. It's the origin extra argument origin. Yes, origin one. It does the same thing as doing this. The other one that I have is the tolerance comparison. So instead of doing quad city gets 10 like you do in dialog, you use the tolerance extra argument, and the shorthand is the approximately equal symbol. So I can do equals with if I do like 1 equals 1.1, that's obviously false. But if I set the tolerance to 100, so absolute tolerance 100, it says that they're equal. The last one is backwards, which for now isn't really useful, but for example, it gives you the last index. So if I do 1 to 1 and I find the index of 1, it gives me 0. But if I say backwards, it gives me the last one, so 2. There will probably be more next versions, but for now, these are the ones that I added right now. But yeah, the extensibility is really interesting because you can pass whatever argument you want to user-defined functions, right? So you can define a set of arguments that your library supports, and then you can define your own shorthands for that. So it's more extensible than the quad IO and quad CT system because you can pass whatever you want.
You said you can define your own shorthands, like as a user?
Yeah, just normal operator. You say hello.
Oh, I see. I thought you meant like a glyph parameter or a glyph primitive if you wanted. So, I mean, this is super cool. My immediate first question was, did you borrow Phil from Uiua? Uiua has another chance to be. There we go, folks. So, Outer Product didn't come from Uiua, but Phil did. So, add it to the wiki.
It works in less cases. In Uiua, you can do fill on the sum, for example. You can do fill 0 sum. If I do 3, 2, and 1, 4, 5, there's just add 0 at the end here implicitly. I don't support it because I think it's not really useful. If you want to do that, you can couple fill. You can couple fill and then you can reduce with the sum. This works in TinyAPL as well. You can do, if I do what's this example? No, 3, 2, and 4, 5, 6. Yeah, you can't add them, and you can't add them with fill either. Sorry, I keep doing the same mistake. Yeah, you can't add them anyway. But what you can do is couple them, and then do a plus reduction.
Right.
Yeah.
Very interesting. And yes, now we can go update the wiki page to say that there's a small influence. Yeah, we do have one question in the chat, which is not too related. I'm not sure if this person is a big JQ fan, but they say, "Have you ever used JQ?"
Is JQ the JSON language?
It is, yeah. I have not ever used it. I am only aware of it because it is.
I've used it for like very small things, like querying a JSON file, but I've not done the actual programming in that. No, I just use it as a small tool, I guess.
Yeah, I had a coworker mention JQ to me once and said, "Oh, this stuff seems like if you like APL, you'd like JQ," and that's the extent. And I've also seen it on my PL Rank website. It's in the top 10 functional languages. So that's the other place that I see it from time to time. So. But I think that is the last question. So with that, I think we're only a tiny bit over time. But this has been fantastic. We're definitely going to have you back in the future because, this was a awesome conversation, not just about TinyAPL, Strawberry, and Omnibar. I've learned some stuff about Omnibar that I didn't know was possible and that I knew I wanted, but didn't think it was possible. Found out that it is. And we saw some BQM, we saw some Uiua. What are the languages? I guess we didn't see any cap, but maybe we'll whip out some cap next time. Anyways, thank you so much, Madeline. Excited to see what you do with Strawberry and also to see .12 get released and on the road to 1.0. I'm sure we'll have you back on a Raycast as well. And yeah, this has been absolutely awesome. Thank you for taking the time to come on. And hopefully we'll be able to do this again in the future.
Thank you for having me. This was great.
Awesome. Until next time, have a good one.